Hi, I'm James Hetherington. I'm the Director of the Advanced Research Computing Centre at University College London, and I'm going to speak about trusted research environments as part of the lecture series for the Digital Health Hub. Our objective in this lecture is to try to understand the key concepts involved in work on trusted research environments to enable us to think about possible future directions and research topics in that area. I'm going to introduce the question by imagining some people having a quick conversation. So there's the blue person and the green person in these speech bubbles are having a little chat. And the blue person is suggesting that it might be a good idea to analyze some interesting health records for the purposes of saving some lives. That sounds good. The blue person is saying, I've got some health data and I'd like you to analyze it for me. We're going to save some lives. The researcher says, great, can I put them on my laptop where all my code is, where I do my working life? No, clearly you can't do that. What if somebody stole your laptop? They would have access to all of that patient data, would all be leaked all over the media. We would lose the trust of society in using data analysis to try to do good. So what should I do? Well, use a secure environment that we built that's designed for handling that kind of sensitive data. Great. That seems like a sensible choice. Those are what we mean by trusted research environments. But there's a problem. The green person is wanting to do some nice modern artificial intelligence research, and he needs a bunch of software libraries, and he needs a powerful computer to do that work. And the environment that's been built doesn't have that. Oh, that's going to be a bit of a problem then. That's going to stall this research. Right? And this challenge of how do we create the computational environments that are secure for working with sensitive and confidential data, and yet have all the tools for modern research sufficiently powerful and so on, is this challenge around trusted research environments. That's one of the areas that we work on in the Advanced Research Computing Centre. In this talk, I'm going to try not to spend a great deal of time talking about particular trusted research environments that are out there. I won't make detailed reference to all the formal compliance standards that exist that you need to get your environment certified under. I won't show the code we use to create them or any of the maths we use to think about anonymization. What I'm trying to focus on here is an introduction to the concepts that we think about when we're worrying about how to build TREs. Trusted research environments give data providers the reassurance that sensitive data is not going to be exposed. However, as I alluded to in that example with the speech bubbles, the experience results from that from scientists can be restricted and cumbersome with tools and software libraries not easy to install or access. We usually think of that primarily as a challenge because it will slow down research. It's cumbersome, it's unproductive. But there's a more subtle problem than that, which is it changes what research is done. Because if we don't have environments that are convenient to work in, then people will choose not to work on those problems, right? And your access to scientific talent to work on that particular data set, on that particular challenge, to use those methodologies will be lost. It influences what research happens. Therefore, a research and innovation community is forming around this challenge, and I'm going to try and talk about those concepts. What I want to get across today is the things that I hope people need to know in order for health researchers to interact with people like me, computer nerds like me, who are building these kind of environments so we can have those dialogues. All right, so the basic concept of a trusted research environment is that I will put my sensitive data in a secure data center somewhere, all the computer analysis is over there, and then on my laptop, I will have a remote connection that I can use to talk to the thing. I can't copy the data onto my physical machine. All I can do is get a window onto wherever that remote system is. That's what we mean by a trusted research environment. But there's a problem. What if I just take my phone out and photograph my computer screen? Now I've got the data outside the secure environment. There's nothing we can do about that. It's impossible unless you actually require someone to go into a secure room, take their phone off them, search them, right? It's impossible to prevent this photographic hole, right? So therefore, everything we do in designing a trusted research environment is attempting to minimize the possibility of accidental or malicious extraction of data from the environment. We are not going to be able to completely block that. And you'll often get users saying, well, since I could just photograph my laptop, why not just let me get the data out, right? If you can't block it provably, completely, what's the point of doing it at all? But what we're trying to do, you see, is to put in a set of controls which will make it less likely that somebody will act in a way which puts the data at risk. There won't be a copy out command. So in order to get the data out, you have to do something that feels unintended, right? Like sneakily photographing your computer. And so that's an important thing to get across. And therefore, it's always a balance. Now, another thing people will often say is, well, I'll just take the names out of that data, right? You say it's sensitive health records. I can see why I wouldn't want those published all over the internet. But if I take the name out of that record and the NHS number, then it's anonymous. That's fine. There's no risk in that, right? I can analyze that on my laptop. Great. That's so much more convenient for me than having to use a secure remote environment. Oh, really? Says the blue person. But if I have this record's age and the fact they live in a particular town, and let's say I've got some data on what kind of exercise people are doing, I've got the fact they're a keen tennis player, it's going to be pretty easy to reconstruct which individual that is. And so the fact that data is disclosurative of an individual identity emerges from things in the data, even if you think you've taken out the names, right? And there's lots of interesting theories about this, but the key concept that I'm just trying to get the concepts across in this introduction. And that concept, right, that there is a possibility of reconstructing an identity from aspects of data, particularly when you join it, in this case with some published results from the tennis club in Kendal, right? By linking data sets together, you can turn things you thought was not personally identifying data into data that is personally identifying. And so that's one of the key challenges. And what does that mean? Well, that means that we need to think about this in terms of the likelihood that data will be able to be re-identified and use that to determine what the controls we impose on the trusted research environment for that data. If we were to just say anything where there's the slightest chance that it might be re-identified, we'll put all the same controls on it as if we were actually working with data with names in, then we're costing ourselves productivity because the controls are too severe for the likelihood of that data being re-identified, right? That data being turned into something where people can see individuals in it. So therefore, we need a balance between the risk or threat, who wants the data, what could they do with it, and what set of controls we impose. So for example, right now this is a table from a particular TRE's approach to the different sets of controls it imposes and different tiers of data sensitivity. I don't want people to focus on, Particular thing here is that the internet is not accessible to copy data in at tier 3 and 4, but it is accessible in tier 0 and 1 of sensitivity or any other particular set of controls. The concept I'm trying to get across here is that as TRE designers or data stakeholders or users or people working in this space, thinking about which kinds of controls we impose for which tiers, and the fact that there are these different categories of data sensitivity. I don't even particularly care that we've gone for 5 tiers, right, in this model. You can, when you design your environment, you might want to come up with different categories of data sensitivity. But the concept that you need to think about the degree of sensitivity of data and thereby the set of controls that you need is important. And we'll probably end up with, this is one that we built at the Alan Turing Institute. You may or may not be able to see the particular questions on this screen, but this is a process whereby we go through deciding which tier a particular data set should be allocated to. Now, one of the things that we need to do in order to make that secure environment is to decide what kind of tools people have inside that environment. Because a researcher will come along and say, I want this particular Python library, or I want this particular R library, or I want this particular tool for analyzing data. And at some sensitivity tiers, we will want to be careful about what software tools they're allowed to have in the environment. Why? Surely all of those things are fine. But there have been examples, and this is a point that I really wanted to get across. There have been examples of people putting malicious code into other people's software and it not being discovered for quite a few months that malicious code has been inserted into the tool. So at the more sensitive tiers, we'll want to review all software tools before they can be onboarded into the environment. So let's think about a particular control that we might want to impose on a trusted research environment. Control over what kinds of software tools are available in the environment. Now you may think, well, let's just make anything available to the researcher that they want. Any R package or Python package that they ask for, any statistical library that they ask for. But for most sensitive data, that can be a risk because we've seen examples where bad actors, the red person in this diagram, insert malicious code into libraries, which doesn't do anything, and then months later, sends data to a place it shouldn't, right? Or other things like that. So, for some tiers of sensitive data, we need to review each software tool or each library, each piece of code that a researcher might use before it's allowed into the environment, as well as reviewing the data. But you can see how irritating this would be. I need to fill in a 10-page Word form and go through a review process before I'm allowed to install another R package, right? So this is a nice example of where selecting the appropriate controls for the appropriate sensitivities of data is a necessary trade-off as we go through those tiers. For example, we may say that tier 3 sensitive data, where we know it's got names in, every software package has to be independently reviewed before it can be used, whereas for tier 1 data, which might in some circumstances be data which has very low probability of being re-identified, all the identifiers have been removed and we don't think you can do the trick with the Kendall Tennis Club, we might just say you can freely install software from the internet. Those are the decisions we make when we're defining the set of sensitivity tiers for an environment. Another question we need to consider is shown in this dialogue. Often people think that data which is publicly available can't be sensitive. All right, I'm going to download everyone's Twitter and then do some language processing across everyone's Twitter to see various things. But what if you analyze that data and use it to learn things? It's public data, right? Anyone can download everybody's Twitter, put it on the internet. But I might from that generate information about, let's say, who might be likely to be vulnerable to becoming a victim of fraud, right? That information is really useful to criminals, for example. And there's lots of other examples like that. So you can make data more sensitive by processing it. And that means that it's actually a misnomer to say that we're classifying data, because if what you do with the data can make it more sensitive, can change the sensitivity, then you're classifying the data and the task and the project and the work. So I often say sensitivity tier is a property of the work package of a research project rather than just a property of a data set or data sets. Another challenge that we need to be careful to pay attention to is that you can't tell whether or not data is sensitive just from looking at the contents of the file. So one example I like to reference is that we've removed all the metadata referring to particular individuals. It's just some medical images, some brain scans of some people. We've taken all the names out. So therefore, that's a lower sensitivity tier of data. But we've actually seen examples, this is quite a common problem, where the patient's name is still there in the image as part of the photograph because it was on the scanner screen, or someone's got a name badge on, or something like that, right? So that's, identify a burn in that example. This is particularly problematic with trained AIs, because what the numbers, when you actually look at the data file of a trained neural network, it's just some numbers, right? It's just 0.7852326 and 0.987654 and so on and so on and so on, all those weights in the network. And you think that it doesn't contain that data. We're seeing examples where by crafting questions carefully, you can discover that personally identifying information which was used to train the AI can be recovered, but only if you ask the right questions really carefully. So that's a really interesting area in terms of trying to understand if we've got the secure environment and inside the secure environment, train an AI and then take the AI out, it can actually leak out the sensitive information. So this is what leads to something we call the 5 safes framework. Only one of these safe settings is this business about building a secure environment. Right? We also need to verify that the people that we allow into our environment are properly trained and have been vetted. That's safe people. We've seen that the design of projects can influence the sensitivity of things. We've seen in our examples that it's possible to reduce the risk by taking some information out of data sets. We've seen that we can carefully control the way in which we take those conclusions from the sensitive data. We've seen that we need to have careful processes around verifying that the things that come out are themselves appropriate to extract from the secure environment, from the trusted research environment. And so these are all things that were within this 5 safes framework. And therefore, it's important to remember that when we set up a trusted research environment, that my part, writing the code which creates that secure environment, is only a small subset of what we need to do in order to build that secure environment, because managing a trusted research environment involves a set of social processes. The processes that we do to determine which data can be brought in, what tier it needs to be in, reviewing data before it can be taken out, verifying that your users are properly trained, and lots and lots of other processes. However, software systems can give us the capability to run those processes in a way that is repeatable and auditable, so that we've got that record of that the processes that we've explained to the data owners that we're going to follow have in fact been followed. So this joining together of appropriate design of social processes, who's going to peer review data before you extract it, all of those kind of things. There's a partnership between that and the technology community in building the tools that underpin those processes, building the IT systems that underpin those processes in order to effectively ensure that we can demonstrate that we have a secure environment. And people that work on these things, we draw big diagrams of which people do what pieces of work. Here we can see that a referee scrutinizes a project and classifies a work package, right, or whatever. I don't want people to get bogged down in the details of this diagram. Just pulled it out from one of our papers. But what I'm trying to get across is that all of those different processes, underpinned by the IT that they run on, is a part of what it takes to build a TRE, as well as the actual secure environment where you do the analysis itself. People often think of the TRE, right, just as the secure place you go to do the work, the remote environment where all the analysis happens, but it's just as important to have the IT that underpins the fact that Bob has had his training properly, right? Or the fact that when somebody says, I'd like to take this graph out and stick it in a paper, Sally's refereed that. All of those processes are also part of the environment. Now, modern software systems, of the kind I've been describing, are constructed through an approach we call infrastructure as code. What that means is that place in the cloud or wherever where the secure environment is constructed, where the IT process that underpins classification or user training or whatever, we write some scripts which, when they run, completely create that environment. There is nothing about that environment which is somebody's gone into a computer somewhere and typed some commands to make it go. Everything about the environment, a robot's gone and made it by following our instruction. I mean, not really a robot, right? It's just software. But the computers, the systems, have constructed that environment by following the recipe that we've defined in our code, which specifies how the environment should be. And this is critical to effective TREs because that code, which constructs the environment, can be audited. It can be reviewed by people who want to. I'm going to give you some really sensitive and important data. How can I be sure that the trusted research environment you've created is appropriately secure? Everything about that environment is characterized in the code that we use to create that environment. So people can audit that our environment is as secure as we claim it is by reading that code. And it's because of that systems that are not constructed through an infrastructure code basis, but instead have people manually maintaining them, typing in commands, we can't be sure what state they're in. Right? So as a principle, think about it this way. If somebody came along and deleted your whole environment, could you construct it again just by saying, run this code, press return? And the computer goes away, blah, 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 and the environment's reconstructed again. If it's like that, right, then you've got infrastructure as code, and therefore everything about that environment is knowable to somebody who reads the code, and therefore you have an auditable system. Right? If it's not like that, if somebody coming along and blowing up your data center means you've lost something, I mean, maybe you've lost the data that's currently inside it that day, maybe because I don't know what your backup frequency is, but if somebody blowing up your data center is anything other than, well, fine, I don't mind, I'm going to run my code and reconstruct my environment somewhere else, then you've got a problem. All right. Infrastructure as code also changes the economics of trusted research environments. We used to often have a situation where we have the same controls regardless of data sensitivity for anything that's remotely sensitive, because it's expensive and complicated to construct ourselves a secure environment. But as soon as you've got infrastructure as code, as soon as you've got a cloud that you can point that code at and create yourself a computer system, then we can give ourselves a TRE factory right? I can make a secure environment for your project unique to you with the controls set as specified by your data donors, with it being no more expensive to make a one just for you and just for him and just for her and just for him and just for her. That's not more expensive, because all I'm doing is I'm just taking the code and I'm pressing return and I'm creating one. Right? I can do that as many times as you like. I can do it automatically. Can do it 5 times before breakfast, right? And that is why our ability to be more fine-grained with our security controls appropriate to the risk and threat environment has been shifted by the advent of the cloud and the advent of infrastructure as code. It also means that research communities can collaborate on the code that underpins trusted research environments. The code that underpins the trusted research environment that's running on the current project in UCLH is one that's also a modified version of the code that's running for one in Manchester, right? It's a different trusted research environment. It's a different instantiation of that environment, but the code that creates it is common. That's really powerful because we can add capability and features to it in collaboration across the research community. And there's another reason it's important. So, if I've got my code that creates my secure environment, I can share that around the research community. I can even just put it on the public internet as open source. Now, you might say, hang on, James, if you put that code on the internet, the code that makes a secure environment, any criminal who wants to know whether or not there are any security flaws in it is just going to come along, read that code, work out what the flaws are, and hack into you. And you often hear that argument used to say why we shouldn't, for secure things, work in this open and sharing code way. But that's not right, in my opinion, and in the opinion of many people who work in this space. The idea that keeping information secret about your software system gives you security. We call it security through obscurity. If your system is insecure because of a bug, the more you share that code, the more good people will review it for you, audit it, and verify that it's safe. So we increase our security by getting, we say, more eyeballs on the code means it's more likely to be well checked and well tested. Right, so, that's why we try not to believe in security through obscurity. And so by working together as a research community on trusted research environments and building a common code base together, we can create a highly productive and secure environment that researchers can work in together, appropriate to the individual sensitive tiers of individual data sets and reusable across multiple parts of the research community. There's one other tidbit that I wanted to share before concluding, which is a really interesting alternative approach that's emerging to actually allow people to start to do their research on their own computers outside secure environments. And it works like this. Inside the secure environment, I take my sensitive data, and from it, I create a new data set, which is made up. Call it synthetic data. It's the same structure. If it's a table with 5 columns, the first one's somebody's name, the second one is their age, and the third one is the date of the last time they had COVID or something, right? I'm making up a research problem. Then the synthetic data, the artificial data, will have the same structure. It'll have the same columns. I'll invent some random people and invent some random ages. Then you write your analysis to run on the fictional data. And because it's the same structure, you can get the code working, right? You can write your statistical analysis. You can write your R code to analyze that data. The results will be meaningless, bonkers, because it's just made up data. None of the people in it are real. But you can get the code written, and then, back in the secure environment again, run the same code on the real sensitive data, and now get the results out. So this is an approach that Ben Goldacre led in his Open Safely project, and it's a different one from the normal trusted research environments approach, right? Where we have a computer somewhere which constructs for us a fictional data set that's structurally similar to the real data. You do your analysis on the sensitive data, you give the analysis code back to the secure environment, and then it runs it on the real one and gives you the results. That's a sort of new approach that's emerging, one worth thinking about. All right, so I'm going to conclude, as we're doing for all these Digital Health Hub lectures, with some further reading. Many of the figures and so on from this talk are taken from our paper. The first link there, Design Choices for a Productive, Secure, Data-Intensive Research to Scale in the Cloud. You will find that a lot of the modern thinking in the health space around this emerges from a review that Ben Goldacre from Oxford did, which I've cited there, which is excellent reading. DARE UK is a set of projects funded by UKRI, operated through Health Data Research UK and Administrative Data Research UK. There are several projects that we've been involved in within that. All the results of the research around the DARE UK program is really worth reading if you want some more interesting details on the kind of things we're thinking about in the sort of TRE design space. Thank you to obviously the funding for the Digital Health Hub, but also DARE UK funding we had, in particular the Standardised Architecture for Trusted Research Environments grant, and the EPSRC funding for the Alan Turing Institute, which also funded some of this work as well. And thank you very much.